Hi everyone, today I'll be presenting the result of the hypothesis test.
I'll be explaining my data set right now. I'll be hypothesis testing. The claim I'm testing right now is the average screen time for school children aged 6 to 14 in Singapore have an average screen time of 2.77 hours per day. To test this, I use null and alternative hypothesis. The null is B. It is 2.77 hours, while alternative would be 2. It is not 2.77 hours. I use a two-tailed test because we want to check whether the average is either higher or lower than the claim value. I'll be presenting my p-value and the test statistics using Excel. The p-value came out to be 0.001, which is less than our significance level of 0.05. Therefore, we reject the null hypothesis. This suggests that the average screen time for children in this sample differs significantly from the claimed 2.77 hours per day. I use my spreadsheet. I'll be demonstrating my formula over here on this Excel. To calculate the sample mean, in Excel I use the average formula to get the answer 3.48333, while for sample standard deviation, I use S equals std.p range, which gave me a value of 1.4158. I'll be explaining the test statistic. I calculated the statistic using this formula, where x is the sample mean, u is the claim mean, as a is the sample size over the a is the standard deviation over the square root of the sample size. Sorry about that. My problem approach and critical analysis would be the reason I chose this data set was collected through a survey. Results are reliable and representative. Given that we are working with the sample data and not our entire population, the z-test was the appropriate statistical test. The standard deviation is relatively large and we don't know the population standard deviation, making the z-test ideal for this scenario. I'll be interpreting my confidence interval. I constructed a 95% confidence interval for the population using the formula CI equals to sample mean times the z-testing times plus minus the z-testing times times the standard deviation over the square root of the sample size. This gave me an interval from 2.95 hours to 4.01 hours. This means we are 95% confident and the true population mean for screen time lies within this range. Given this, it seems unlikely that the average is claimed 2.77 hours. Thank you.
To conclude, the hypothesis test shows strong evidence that the average screen time for children in Singapore is different from the claimed 2.77 hours per day. The sample mean was 3.48 hours and the 95% confidence interval suggests the true average lies within 2.95 hours and 4.01 hours. This result provides insight into the screen time habits of children, and it calls into question the accuracy of the reported 2.77 hours claim. Thank you.